I want to look through 3 sample problems that'll help you understand how to use all of these equations. There are a lot of equations and that can seem overwhelming, but really if you just do the guess method and find the one that has the variables that you're given and that the problem is asking for, it shouldn't be that big of a deal. So, how long will it take? So let's stop right there. We can already look at this. How long will it take? Well, how long means we're looking for time, right? So that's already our unknown. We know that that's going to be our U, time, right? I've already done that step. How long will it take a 500 watt coffee pot? 500 watts, I know that W stands for watts, which is the unit for power. If you're a little confused by that, that's just going to take some time to go back and look at your notes. The W that comes after a number is watts, which is the unit for power. How long will it take a 500 watt coffee pot to, get rid of this word, to heat up water if such a task requires 500,000 joules of energy? So guess method, we've used this so many times. It works for every single problem. Just write down what it gives you. We know that power is 500 watts. And we know that energy, it says energy right here, and you should know that joules is the unit for energy. Energy is 500,000 joules. Right? Again, we know that the unknown is time, and then we're going to look for the equation. If we look through the equation, we need an equation that has time, because obviously time is what we're trying to find, and has E and P as well, because those are the things that the problem gives us. So if you look through the equations that you wrote down in your notes, you will find that the only equation that has E, P, and T in it is the equation E equals PT. That was in the electric energy slide. So this one should be really simple and straightforward for our substitute and solve step. We're going to substitute 500,000 in here for energy, since that's our E. P is 500. And time is what we're solving for, so I'm going to leave it the way it is. To solve for that, we will divide by 500 on both sides. Boom, boom. Get rid of those zeros. Sorry, should get rid of those zeros. 500,000 divided by 500 is 1,000. Now, that may not mean much to us, 1,000 seconds. But if you go and divide that by 60, let's see here, 1,000 divided by 60 gives us about 16.7 minutes, right? Which this problem isn't written realistically. That's pretty long for a coffee pot to heat water, but 500 watts maybe is not very much power, or maybe this is a lot of water to heat. But 1,000 seconds would be the answer to this question. All right, let's go to the next one. It says how much current will run through the coffee pot. Now, this is the same coffee pot, right? The same one we looked at before. And so we're looking at all these variables here, all the things that we already know. These are going to be able to be taken into account with the next problem, right? So the power of the coffee pot, the energy that it takes to warm the water. So this says how much current will run through the coffee pot if it's plugged into the wall, which has a potential difference of 120 volts. Remember, potential difference is the same thing as voltage, right? So givens, once again, from before the power was 500 watts, from before the energy was 500,000 joules. All of that is still at play here. This should be a comma, I'm sorry. But now we also know the voltage, which is 120 volts. And technically we found the time before as well. Time was 1,000 seconds. We can use that as a given as well. We may or may not need it. The unknown, how much current? Remember, current is I. I is what we want to know. So realize, I want you to see this. If you got all this stuff lined up right here, it's super easy to find an equation. You got to find one that definitely has I in it. It's got to have that. And then it's got to have some combination of these. It doesn't have to have all of them, but it's got to have some of them. So if we look again in the equations that you were presented with today, the equation that has I and some combination of all of those other ones is, well, there may be a few of them. So I see P equals IV. We could use that. We also could use E equals VIT. Okay. Either one of those can be used and you're going to get the same answer. You just need to know that with this electricity stuff, if you find two equations that can work, as long as it's got your unknown in it, right, which this one, they both have I, and everything else in the equation is a known, right? We know power and we know voltage. We're cool there. We know energy, voltage, and time. We're cool there. Then we can use either of those equations and get the same answer, right? You're just going to need to trust me on that. And if you want to, you can go ahead and do your calculations with that equation, because I'm not going to do it. I'm going to do it with the shorter, easier equation, P equals IV. So let's just plug in and solve. P is 500, I is what we're looking for, and V is our new information. It's 120. To solve for I, all we need to do is divide by 120. 500 divided by 120 is 4.16. We'll just call that 4.2. I equals 4.2 amps is what you should get from that one, right? Take a look at that. Pause the video if you need to. Make sure that that makes sense. And then let's go ahead and look at this one. Okay, so for this one, I want you to pause the video and see if you can figure out how to do this one on your own, and then I'll come back and look at it. Okay, so let's go ahead and go through this one a little bit quicker here. Hairdryer uses 120 volts, that's voltage, while pulling 10A. A is amps, amps is current, current variable is I. While pulling 10 amps of current, if it takes 5 minutes, that's time. And remember, that will need to be converted to seconds before we use it. We can't use minutes. If it takes 5 minutes to dry your hair, how much total energy, looking for E, how much energy is used? All right, so let's use our guess method here. We know that voltage is 120 volts. We know that I current is 10 amps. And the time is 5 minutes, which 5 times 60, make sure I'm doing this right here, 5 times 60 is 300 seconds. That's the time that we're going to use, not this one, right? We don't want to use minutes, right? And the unknown, how much energy is used, E is our unknown here, right? So now we look for the equation that has to have E, that's got to have that one to solve for it, and then V, I, and T as well. And if you look closely, there's one that looks like this that I gave you, E equals PT equals VIT. We can't use all of that equation. We only need 2 parts of it. And so for this one, we can actually just get rid of the middle part and go with E equals VIT. And this one gets real dirt simple. We just are simply going to multiply these 120 times 10 times 300 seconds. So 120 times 10 times 300 is 360,000, looks like. 360,000, and remember this is energy. The unit is joules. Real simple calculation, shouldn't be very difficult. Simple and straightforward on that one.